In this lesson, we will learn the difference between mass and weight. Now, mass is the amount of matter present in the body of an object. When we say matter, means we know all matter, all objects are made up of atoms and molecules. So, mass is these atoms and molecules present in an object. Now, if you take an example of this book. What you mean by the mass of this book is all these molecules of paper present in the book is called the matter or the mass. Take the example of the chair. The chair is made up of all these atoms and molecules, and this consists the mass of these objects. You definitely agree that the mass of an object will remain constant, maybe on Earth, maybe on Moon, or anywhere in the universe. The mass of an object will always be constant because it is the atoms or molecules that are present in that object. Now, to discuss some properties of mass, first we've seen that the mass always remains constant. Anywhere in the universe, the mass of an object is the same. Next, the unit of mass. Now, the SI unit of mass is kilogram. And we write it as kg. That is the SI unit. And the next point to remember that mass is a scalar quantity. And by scalar quantity, we mean a quantity that has only magnitude and no direction. Mass has only magnitude, no direction. Now, weight. Weight is the force with which it is attracted. The object is attracted by the earth. And we have seen that every object is attracted towards the earth with a force. This force is equal to weight. And by Newton's second law, we know that force equal to mass into acceleration. We will use this second law to find the formula for weight. In our case, we said what was weight? Is the force with which an object is attracted to the earth. So now for force, I'm going to put weight because weight is the force with which this mass m, say this body with mass m, is attracted towards the earth. And there is an acceleration here which is called acceleration due to gravity, that is g. So here will be mass, and this acceleration will be acceleration due to gravity, which means we can write the formula W equal to m into g. Now, looking at this formula, if I were to ask you the question, on which two factors does weight depend? And you'll definitely agree and tell me that it depends on two factors: mass of the body and the acceleration due to gravity. If the acceleration due to gravity decreases, the weight decreases. If the acceleration due to gravity increases, the weight increases. However, the mass remains constant. So the weight depends a lot on acceleration due to gravity at that area, in that region. The weight will depend on the acceleration due to gravity. So the next question is weight constant? Now we know that weight depends on acceleration due to gravity. So weight is not constant. Unlike mass is constant, weight is not constant. We'll discuss this more in detail. We will find out where do we weigh more. Do we weigh more on the earth or on the moon? Or is our weight the same? Next, we see that weight is a force, and force is always a scalar quantity. So next property we learn is weight is a scalar, not a scalar, it will be a vector quantity, because remember it is a force, it is a vector quantity. And why vector quantity? It has both direction as well as magnitude, and the direction is always towards the earth. The direction of weight is towards the center of the earth. It's always directed towards the center of the earth. And then we know the SI unit of weight. The SI unit of weight will be just like that of force, because weight is force. So SI unit is Newton. So we write it as N. In this slide we'll learn how the weight of an object is different in different planets. To know that, we must first learn the formula for weight. We know weight equal to mass into acceleration due to gravity. Now acceleration due to gravity of a planet is given by the formula g, gravitational constant, mass of the planet over the radius of the planet, radius square of the planet. So the g of the acceleration due to gravity of a planet will depend on its two factors. Will depend on the mass of the planet, and it will depend on the radius of the planet. Now since planets have different masses and different radii, you expect the acceleration due to gravity will be different for different planets. When it comes to Earth, the acceleration due to gravity on Earth is 9.8 meter per second square. When it comes to Moon, since Moon is smaller, the radius also smaller, the acceleration due to gravity comes to 1.6 meter per second square. And at Jupiter, which is the largest planet, the acceleration due to gravity is 24.58 meter per second square, a huge acceleration to gravity. So if an object has mass, say 10 kgs, what would be its weight on Earth? It would be mass, which is 10 into acceleration to gravity 9.8. So this would be 98 newtons on Earth, the weight on the Earth. Now let's go ahead and see what would be its weight on the Moon. Again, mass, which is 10 into acceleration to gravity is 1.6. So it would be 16 newtons on the Moon. And on Jupiter, weight is mass, which is 10. Acceleration due to gravity is 24.5. So its weight here will be 245 newtons. So if you have noticed, the weight on Jupiter is very large. And due to this large weight, great weight on Jupiter, it would be impossible for a person to walk on Jupiter, because it would require a large amount of force to overcome its weight. The point we try to make here is that the weight of an object depends on its mass, which remains constant, but also it depends on the acceleration due to gravity at that place, at that planet. We'll see about the weight of an object as it moves away from the Earth. What will happen to its weight? As an object moves away from the Earth, we know the acceleration due to gravity decreases. And if acceleration due to gravity decreases, the weight also will decrease. So as we move away from the Earth, our weight slowly keeps decreasing, and when we get into space, in space g is 0. So our weight will be mass into g, mass into 0. So weight is 0. So in space, since acceleration due to gravity is 0, our weight is also 0. It will be interesting to note that our weight on the earth also is not constant. This is because the earth is not a perfect sphere. At the equator, the radius is large, the equatorial radius is large, but at the pole, the polar radius is less. Now, because equatorial radius is large, the g at the equator is small, because we know g is gm over r square. Here the denominator is large, so g is small. And if g is small, you'll definitely agree the weight will be less. Weight is less at the equator. But when we come to the pole, at the pole the radius is less, and because the radius of the earth is less, the acceleration due to gravity at the pole is more. Because I repeat again, g is gm over r square. The denominator is small, so the fraction becomes large. If g is more at the pole, the weight at the pole is more. So we weigh much more at the pole, and at the equator our weight is less. And if you were to write this answer, these are the points you need to include. First, Earth is not perfect square. I mean, not a perfect sphere. First point. Bulging at the equator and flattened at the pole. So, our equatorial radius is more than the polar radius. Is more than the polar radius due to its shape. Now, if equatorial radius is more than the polar radius, which means acceleration due to gravity at the equator is less than acceleration due to gravity at the pole. And hence, for the last point, the weight at the equator will be less than weight at the pole. The weight of an object is 10 kgs, or the mass of an object is 10 kgs. What is its weight on the earth? So 10 kgs is mass. We must find the weight. And the formula for weight is mass into acceleration due to gravity of the earth. So we saw the mass is 10, acceleration due to gravity on the earth is 9.8 meter per second square. So this is 98. It has to be newtons.